Right, so now we're drawing the circuit where we have this EMF right here, and then we have the internal resistance right here. So we're just treating it like another resistor that's in the circuit. But let's consider this circuit. Now, each component of this circuit has either a drop or a rise in the amount of energy that it imparts to the charges that are going through it. That is, in the energy per charge, or the potential for the charges as they go through. So those electrons, as they're traveling through the circuit, are either going to gain or lose energy. And you can imagine, you probably know actually, which ones they gain and which ones they lose energy. The electrons are going to gain energy when they go through the battery, and then they'll lose energy when they go through the resistors, as they do whatever it is that they're going to do when they go through the resistors. They might act as a source of heat for a heater, for example, or for a source of light in a light bulb, or to run a motor, or whatever it is that you want it to do. So in these components, they will gain energy in the battery or the power supply. I'm going to show battery. Or if you want to say this is the source of EMF, they're going to lose energy in the resistors. And this energy will go into whatever you want it to do. Now, a lot of the energy is going to go into heat or thermal energy, but it might also go into light, if it's like a light bulb, or mechanical energy if you're running a motor. All right, we'll see later that it can also go into chemical energy as you recharge another battery. Now, each component gives either a drop or a rise in the potential. So here, our change in potential for the EMF source is plus C. For the internal resistance is minus I times R from Ohm's law, and minus I times big R, also from Ohm's law. So when you go around the entire circuit, the change in the potential, as you might imagine, if you come back to the same point where you left off, is going to be equal to 0. So the sums of these are all going to equal 0. So an electron at a particular spot in the circuit will have the same energy when it returns back to that spot. So we would see this, that the change in potential in the loop is going to equal plus the EMF minus the potential lost in the internal resistance minus the potential lost in the other resistor, and those all added up should equal to 0. And then we can solve for the EMF, which is going to equal the internal resistance plus the voltage across the resistor.